Today we'll talk about network layer and logical addressing, and we talk about, as we said, about classful and classless IP addresses. We talk about subnetting, and we talk about DHCP and NAT, network address translation. So what is an IP address? IP address is a 32-bit address, logical address. And if you have 32 bits, you'll get 2 to power 32, which is about 4 billion addresses. These addresses are referred to as IP version 4. So IP version 4 is a 32-bit address. Or simply, if we just say IP, means IP version 4. There is another version, IP version 6. So if we say IP version 6, it means version 6. If we just say IP, it means IP version 4. We see what the difference. Here we have 32 bits. Here we have 128 bits for addressing. Okay, so you'll have much bigger or larger address space, 2 to power 128, which is a very large number. IP version 6 uses 128-bit addresses that give much greater flexibility in address allocation. So may ask or wonder why these 4 billion addresses are not enough. Nowadays everything needs IP address, Internet of Things. So every device you connect to the Internet will need an IP address. So with these technologies, whatever this number of addresses is not enough. Therefore, the direction is to switch to IP version 6. As we said, IP version 4 will have 32 bits. So total addresses, our address space is about 4 billion, 2 to power 32, which is this number. IP addresses are unique. Each address defines only one connection to the Internet. So no two devices connected to the Internet should have the same IP address at the same time. You may use the same IP address of another device, but one of them should be connected at the same time. Two devices on the Internet can never have the same IP address at the same time. There are two notations for IP version 4. We either use the binary notation in binaries, or we call it decimal dotted notation. You see, we have decimals separated by dots. This is called decimal dotted notation. We mostly will use this for IP version 4. So we'll use decimal dotted notation or dotted decimal notation. Dotted because you have these dots, and decimal because we convert these binaries into decimal. Therefore, we call it dotted decimal representation. So here you convert each byte separately into its equivalent decimal, and then put a dot, and then the next byte, and the next byte, and dot, and the last byte. So this is 2 in decimal, this is 29 in decimal, this is 149 in decimal, this is 117 in decimal. As we mentioned before, we have two types of IP addressing, classful addressing. In classful addressing, we classify addresses into classes, 5 classes: class A, class B, class C, D, and E. Okay, so in classful addresses, addresses have distinct classes, 5 distinct classes. If the address is given in binary notation, the first few bits can tell us which class the IP address belongs to. If the address is given in decimal dotted notation, the first byte, the IP address is 32 bits, which equals 4 bytes. So this is the first byte, second byte, third, fourth. Okay, so in decimal notation, decimal dotted notation, this byte can tell us if the class is A or B or C. So if it starts with 0 to 127, it's a class A. If the first number or byte in decimal dotted notation is 1 to 8 up to 191, is class B. If it's 192 to 223, is class C. If it's this range, then it's class D, or if it's this. You can, of course, use the binary notation. In binary is easier, is still easier. If the first byte starts with 0, whatever the other bytes are, whatever the other bits are, doesn't matter. If the first bit is 0 of the first byte, then this is class A. You see now, if the first bits are 1, 0, and the other ones are whatever, this is class B. If the first bits are 1, 1, 0, this is class C. You don't care about the other bits, okay? You just look at these three. If they are 1, 1, 0, this is class C. If you see 1, 0, this is a class B. If you see it begins with 0, this is class A. Class D, you see another one here, 1, 1. So you are just adding ones. Start from 0, then add ones on this side. So 1, 0, 1, 1, 0, 1, 1, 1, 0, and then last class is class E, which starts with 4 ones. Okay, so we have these 5 classes. You should remember these. Either way, you can convert the first byte into binary and tell using this table. This table is very easy to remember. Or you can remember these numbers and then you can tell the IP address class. Although nowadays classful addressing is not very common as before, but still you need to know which class the IP belongs to. The problem with classful addressing is that each class is divided into fixed number of blocks. You see here, so class A, we use the first byte for network address, we call it net ID, and the 3 other bytes for host ID. In class B, we use 2 bytes, first 2 bytes for network ID and the second or last 2 bytes for host ID. In class C, we use 3 bytes, first 3 bytes for network ID, and the last one for host ID. For class D and C, this does not apply. So there is a problem here because we'll explain soon. Class A addresses were designed for large organization. A block in Class A address is too large for almost any organizations. This means most of addresses in a Class A block will be lost. Because you see here, if you have an address in Class A, okay, you can, with one address, you can name how many hosts. You have how many bits here? 32 minus these 8 bits, which equals 24. Okay, so you can, with one address, with one IP address of Class A, you can name 2 to the power 24 hosts, which equals this size. Okay, you see here, I'll just use the calculator to explain. So if you say 2 to the power 24 equals 16 million. So each IP address in Class A, I'll share the screen with you, I think it's better. So each IP address in Class A is you can name or 2 to the power 24, which is 16 million and something hosts. So how many blocks we have? Number of blocks for Class A. You see here we said the first bit of the first byte is 0. So how many bits are left? Because this is 1 byte for network. So 7 bits left. 2 to the power 7 equals what? 128. So we can name, or we can have 128 blocks. And each block can have 16 million hosts inside. So you can give only, say, 128 IP addresses Class A if you want give them full block. So for example, a company like Google or Microsoft can purchase an IP address of Class A, and it can name or give IP addresses to 16 million hosts in its network. This is actually quite big even for large companies, and the number of blocks is limited, so only expect very big companies to have IP addresses in the Class A range. In Class B, you see, we have how many? 2 bytes for network. So the first 2 bits gone here because they should be always 1 0. So we left with 6 here and 8 here, which equals 14. So how many blocks in total we have? 2 to the power 14. 2 to the power 14 equals what? Use the calculator. 2 to the power 14 equals 16,000. So we can have 16,000 blocks. 16,000 and something, 16,000. Okay, so each block can have how many hosts, block size? Each block can have, because we have 16 bits for hosts. 2 to the power 16 equals what? Two to the power 16 equals 65,500 something. So each block will have 65. You can have 65,000 addresses. In class C, you see these 3 bits should be 110. So you have how many bits left in this byte? 5 bits. And you have 8 here, 8 here. So in total, how many? 16 and 21. So 2 to the power 21, which equals how many blocks? You see the blocks will increase. 2 to the power 21, which equals this number. So we have these number of blocks. But each block, you see, can name how many hosts, because it's 8 bits for hosts. So it can name 2 to the power 8. Each block can name 2 to the power 8 hosts, which equals 256. So the blocks here, there are many blocks, but they are small in size. Here there are few blocks, 128 blocks, but they are very big in size. So this IP address, even for large companies, may be big. For example, like Microsoft, 16 million still may be a big number. And this one is small. So maybe IP class B maybe will suit some, but this for a company class C maybe is not enough. For class A maybe it's quite big. So there will be wasting of IP addresses. Class B addresses were designed for mid-size organizations, you see. So each IP in class B, you can name 65,000 hosts with tens of thousands of attached hosts or routers. A block in class B is also very large. It's still 65,000 can be very large for some companies. Probably too large for many of the organizations that received a class B block. So if they don't have this number, they have one IP address, but they didn't use it for 65,000. So maybe they are wasting half of this range. Okay. Class C addresses were designed for small organizations. Class A and class C block is probably too small for many organizations. Okay. Class D is for broadcasting, for multicasting, sorry. Each address in this class is used to define one group of hosts on the internet. We'll study multicasting later. The internet authorities wrongly predicted a need for this number of groups, which never happened, and many addresses. So we still lost many addresses here. So here we lose so many addresses in this classful addressing. Here because companies will, even large companies will not have this number of hosts. Even with class B, you may not have this number, so you waste many of these IP addresses. Class E addresses were reserved for future use. Only a few were used. So still many been wasted. So you see, this classful addressing is very there's a large waste of IP addresses. Therefore, the classless address scheme is now widely adopted. So as we said, in classful addressing, we have IP address in class A and B and C are divided into net IDs, the green ones, and host ID, the white one. Okay, so in class A you have 1 byte, first byte for net ID, I greened them, and the white 3 bytes for host ID. For class B you have 2 bytes for net ID and 2 for host ID. Class C you have 3 bytes for net ID and 1 byte for host ID. For class D and E, this does not apply. You learn about masks a bit, but we'll explain now what are these numbers. Although the length of the net ID and host ID is predetermined in classful addressing, so if you have classful addressing, we say you have an IP address in class A. You know exactly 1 byte is for network and 3 bytes for hosts. So if you enter the IP address in your computer, if you enter a class A address, we'll try it together if you'd like. So if I go to, you see my we need to see the adapter. Change adapter options. So let's change any of these, or not just if you go to properties and you see we are talking about IP version 4 and then check properties. Now if I assign an IP address, I need also mask. So let's use an IP address of class A. Class A, we said, starts from what? What's class A IP address? So I'll do this, for example. This is a class A because it starts with from is less than 128. So anything. Now if I put the cursor here, it automatically knows, because it's class A, it knows that class A's default subnet mask, this is the default one, without subnetting or supernetting. So if you are using default and classful address, it will give you, but of course, as we'll study in this lecture, we can change the default subnet mask to something else, to when we use subnetting or when we use supernetting. So without any change, this is the default mask. Okay. So if you, for example, I'll clear it and then use class B. So class B, I can say, for example, 130. So this is a class B. Now if I put You see 2 bytes for network and 2 bytes for host. If I say class C, for example 193, now you see for the default mask for class C is 3 bytes for network and 1 byte for host. So this is 255 in decimal dotted notation, means in binary 8 ones, again 8 ones and 8 ones, then 8 zeros. So the mask will be what? All ones followed by all zeros. You cannot have in between the ones zeros, like for example it will be something like this. Class, this is the default. You cannot have some zeros here. Okay, they all should be ones and then followed by zeros. So for class A, this is the default mask. Okay, 8 ones, then 8 zeros, 8 zeros in decimal dotted notation, dotted decimal order. We say 255000. We have another notion, is called the CIDR or slash notation or classless interdomain routing, CIDR. This is widely used in classless addressing. So /8 means there are 8 bits for network, or the prefix, network prefix. So this 8 means we have 8 bits for network. This 16 we have 16 bits for network. 24 means 24 bits for network address. So the mask can tell us which part is for network and which part of is for host. With default classful addressing, the mask is trivial because you know this which part, but if you do subnetting, sometimes, for example, use these bits for example, to make subnets. So the default mask will no longer be valid. You change it, for example, instead of 16, you will have 14 or a different number. Okay, so you or you can do supernetting also, as we'll see in the coming slides. Okay, so we have to know all these 3 notations. The binary, the mask is always starts with all ones, then followed by zeros. In decimal dotted notation, you convert it. In CIDR, you say how many bits are for network. /8 means 8 bits for network. /16 means 16 bits for network, and so on. Okay, I'll do this slide and then we'll have a break for until بزحمة بس نوفيت خود شاتي ده ونفرق كان ده السيف كم. نوفيت خود شاتي ده فرق كان ده السيف كين ده. Okay, I'll do this slide and then we'll have break until 11. So in subnetting, you do what? If an organization was granted large block in class A or B, because class A block, as we shown, can name 16 million hosts, which is very big. So they can do divide into several contiguous groups and assign each group to a smaller network. This is called subnets. We'll explain in more detail. Subnetting increases the number of ones in the mask. Okay? So you see here, class A, you have very large networks. So you can take some of these host bits and use them as for network. So the slash 8 can be, for example, slash 12. Okay, so you assigned some of the host bits to network. This is called subnetting. Or you can do the other way. If the network is, you see the number of hosts is 256 in each block in class C. If you want to have larger blocks, then you can combine several class C IP addresses, several blocks, and use some bits here to make a supernet. So in this case, you use these for host. So the number will decrease instead to 22, for example, or whatever number you want. So in this case, you make the network block bigger. In this case, you make it smaller. Okay, so if you have class A and B are almost depleted, therefore class C addresses are small for some organizations, because you can only name how many 256 for each block, which is a small block.